So, good morning. Let us start today's lecture. Today, we are going to discuss about crystallographic and geometric symmetry. This is one of the very important topic in crystallography. That how the different crystals are symmetric and how to measure their symmetry. So, what actually the symmetry is? In geometry, symmetry is defined as a balanced and a proportionate similarity that is found in two halves of an object. So first you should understand that what the symmetry is. Symmetry is actually it develops or it gives a proportionate behavior of any object. Say for example, if you divide any object into two equal halves, if you get exactly similar division or similar halves, then we can say that this object or that object is symmetric in nature. You can see here that in the picture given below, you can see that how the two different objects are shown where one object is symmetric and another object is asymmetric. So, symmetry is a very important and crucial thing in nature. As we know that the mineral crystals are naturally occurring and hence they are not separated from this symmetry. Means the crystals also possesses symmetry. So in this topic, we are going to discuss about how this symmetry is present in the crystals and how it can be measured with the help of different symmetry elements. So what is crystallographic symmetry? In crystallography, fundamental property of the orderly arrangement of atoms found in crystalline solids. Each arrangement of atoms has a certain number of elements of symmetry. So as we know that, if we go back to the definition of mineral, we have seen that the minerals are naturally occurring inorganic substance with definite atomic structure. Okay, when we preferably says that the atomic structure of the crystals are definite, that means their arrangements are in an orderly manner. All atoms and molecules belonging to that crystals are arranged orderly. And as we know that if the atoms or the molecules or any kind of arrangement is in an orderly manner, definitely there will be a development of a symmetry. So usually a crystals whose atoms or constituent molecules are arranged in an orderly manner, they develops a symmetry. And that symmetry is called as crystallographic symmetry. In the picture, you can see the asymmetric nature of the different crystals. You can see that how the diamond is four-sided, and you can see how on dividing the diamond into two equal halves, you will get the symmetric halves. You can also see the quartz, that how the quartz is symmetric. Okay, so this was all about the crystallographic symmetry, as the crystallographic symmetry is somehow related to the orderly arrangement of the molecules and the atoms present in the crystals. Elements of symmetry. To measure this crystallographic symmetry, we have three elements of symmetry. The first is axis of symmetry, the second is plane of symmetry, and the third is center of symmetry. Every every crystal has some sort of elements of symmetry in it. The most symmetric crystal will have maximum number of symmetry elements, whereas the crystals which are less symmetric will have less symmetric elements. Say for example, cube. Cube is the most symmetric crystal in our crystallography, and hence cube shows maximum symmetry elements, whereas triclinic system has less symmetric in nature and hence has least number of elements of symmetry. So when we have to measure the crystallographic symmetry of any crystal, we have to measure on the basis of axis of symmetry, plane of symmetry and center of symmetry. So let us see the axis of symmetry. When an imaginary line can be passed through a crystal such that the crystal can be rotated 360 degrees about the line to fill the same space 2, 3, 4, or 6 times. Now I would like to tell you, I would like to tell that the imaginary line which passes through the crystal can be termed as an axis of symmetry only when you rotate that crystal around that line up to 360-degree, and if the face which you have used as a referred face repeats itself twice, thrice, or 4 or 6 times. At least there should be a repetition of 2. When a single face repeats itself twice on the complete rotation of 360-degree along an imaginary line, then that imaginary line can be called as an axis of symmetry. Uh, I would tell you to focus on the picture in the slide. You can see that how the different imaginary axes are shown around the cube, and how you can see that there is a rotational indicator. If you will rotate that cube along that axis, a referred face or with whatever face you choose will repeat itself for minimum twice times. It can repeat it more than twice. It can repeat it for thrice, for 4 times, or 6 times. Accordingly, their name has been designated as two-fold axis, three-fold axis, four-fold axis, and six-fold axis. So, axis of symmetry in general can be defined as it is a line along which, if the crystal is rotated, a single face or a referred face repeats itself at least for 2 times. It can repeat it for more than 2, but at least there should be a repetition of the 2 to designate that axis as a axis of symmetry. Plane of symmetry. It is an imaginary plane which passes through the center of a crystal and can divide it into two equal portions, which are exactly the mirror image of each other. Yes, of course, this is another element of symmetry where if you divide a crystal with the help of an imaginary plane and the resultant two halves are the mirror images of each other, then in that case, that plane will be termed as the plane of symmetry. In the figure, you can see that how different planes can be used to divide the crystal into two exactly equal halves, which can be mirror image of each other. So this is about the plane of symmetry. So now we have seen two elements of symmetry, axis of symmetry and plane of symmetry. Here in axis of symmetry, you know that the axis is an imaginary axis around which on the rotation of 360-degree, a single referred face repeats itself twice or more than twice. In plane of symmetry, it is a plane along which if you divide the crystal is divided into two exactly equal halves, which can also be the mirror image of each others. So this is the plane of symmetry. Center of symmetry. This is the third and the last element of symmetry. A center of symmetry exists in a crystal if an imaginary line can be extended from any point on its surface throughout its center, and a similar point is present along the line equidistance from the center. So here it is very important to understand that how the center of symmetry is defined. So say for example, if you draw a line from a corner and it passes through a center of that crystal, then it should reach to another corner on the another side of the center. If there are two corners in the two opposite side of the center, then that center can be called as the center of symmetry. And those two corners should be. There was a technical issue. So you can see that how the center of symmetry can be defined. Usually, the crystals with minimum symmetry, at least it has a center of symmetry, like triclinic. Triclinic don't have any plane of symmetry or axis of symmetry, but it has a center of symmetry. Whereas rest of all crystal systems like isometric, tetragonal, uh, orthorhombic, monoclinic, hexagonal, all have axis of symmetry, center of symmetry, and plane of symmetries. Only the triangle system is there, which does not possess any axis or plane of symmetry, but has only a center of symmetry. So this was all about the geometric and crystallographic symmetry. If you have any questions, you can just put your questions in the chat box.